Okay. Hi, everybody. Good evening. I hope everyone is doing great. Right. So I see very less number of people today. 1, 2, 3, 4, 5, 6. 6 of you. What happened? Any exams going on? Anything happening in school? Just a moment, people. Just a moment. Okay. So yeah, so now I see little number of people increasing. So they will just okay. So I think they just disable this admit thing, right? Once the people enters, we don't have to admit, right? So that it will be better, right? Okay. So just give me some time, right? Let me get back to my host position. Okay, I'm back, right? So people,
sir, you can carry on.
Yeah, sure, Raghav. Okay. So the other faculty, I think, has started biomolecules, right? Yes, no?
Yes,
Guys?
sir.
Okay, so he has started biomolecules. Okay. Can I know until what he covered? What and all has been covered? What and all has been covered?
Sir, for us, carbohydrates and protein is over, sir.
Carbohydrates and protein both are over?
Yes, sir.
Okay. So how many classes he took for biomolecules?
Sir, what's it?
How many classes happened for biomolecules?
Sir, I think around 3 to 4.
3 to 4 classes. Okay, okay.
And
So
our exams were coming, so our ma'am just rushed.
sorry.
No, our exams were coming, so she just rushed the portions of biomolecules. So yeah.
Who took biomolecules? That sir took,
She
right?
didn't tell us detail. She just explained the polysaccharide.
No. What I'm asking is, the sir took, right? Other sir, chemistry sir, who was teaching you the other chapters, he only took biomolecules, right? Or some other ma'am took?
Oh yeah.
He only took.
Yes, Anandita, what?
He only took around 2 to 3 classes.
Around 2 to 3 classes. Okay, okay. So you know what is the structure of glucose, you know what are monosaccharides, you know what is the structure of fructose, you know what is a glycosidic linkage, right? You know what is a disaccharide, right? So a disaccharide is basically two monosaccharides attached with each other. How are they going to attach, people? What is the name of the linkage which you have to know?
Peptide.
Sorry?
Is it peptide, sir?
Peptide is for proteins. Now, say if I have sucrose. Sucrose contains two monosaccharides. What are the two monosaccharides?
Glucose and fructose.
Good, right. So glucose is a disaccharide which contains two monosaccharide units. That is your glucose and fructose, right? How is it that these glucose and fructose are attached? What is the name of the bond which you have to know? I actually told the name some few seconds back. What did I tell? Some name I told, right? Some bond, glycos. I think again I'm telling it. What is the, at least now can you finish it? What I started?
Glycosidic linkage.
Glycosidic linkage, right? So I will have H2O molecule removed, right? H from glucose, OH from fructose will be removed, so that you'll be able to form. You'll be able to remove H2O molecule, right? And then you'll be able to form something called as a glycosidic linkage, right? So in your syllabus, I think you have only sucrose, right? But you can have other monosaccharides like, sorry, disaccharides like maltose, right? Galactose, right? All these things you can have, right? But I think those things are not there in your syllabus, right? And you have to know, right? The glycosidic linkage, if it is formed in sucrose, right? You have to understand which carbon atom of sucrose is attached with which carbon atom of fructose. All these details should be known. See, okay, I will actually have to speak to you about something very important, but still we'll just complete this. Okay, so where the glycosidic linkage, whether it's C1 of glucose and say C2 of fructose, we know it is going to be actually C1, C2, right? C1 of glucose and C2 of fructose will form the glycosidic linkage, right? And then you would have studied about Muta rotation. Did you study about Muta rotation? Yes. Or if I have to tell you the name which you will understand, inversion of cane sugar. Did you study the reaction? Inversion of cane sugar.
He gave a definition for it, sir.
Okay, what is the definition you know? Tell me.
Rotation of pure glucose or pure alpha glucose and beta glucose over time to reach an equilibrium value is called Muta rotation.
Okay, okay. So, yeah, basically you have, for example, we know that stereochemistry, like we know how optical isomerism will come into the picture, right? Say your sucrose, right? Your sucrose is going to have some plus value. We know what do you mean by plus, what do you mean by minus. Plus means D, minus means L, and that is basically denoting what? The plane polarized light, whether it is shifting towards right, then it is plus. If it is shifting towards left, I think what, like for you it will be opposite. Okay, if it is shifting towards left, it's my left here, right? Then it is going to be L or minus. We give a sign as minus, right? So sucrose, you will see that it will be plus sign, right? Now when I hydrolyze sucrose, when sucrose undergoes hydrolysis, what is going to happen? Sucrose on hydrolysis will give me, sorry, in home, this is sounds very common, right? Just give me a moment. Yeah. So when sucrose undergoes hydrolysis, when I add water to sucrose, it is going to form the monomers. That is your monosaccharides. That is your glucose and fructose, right? So what will happen there is the plus value which I have for sucrose will convert into a negative value. And as Rohan said, I'm going to have some kind of equilibrium existing between glucose and fructose, right? So that I'm going to get some equilibrium value, but that value will be a negative value. That's what you have to understand. So plus becomes minus. That is what is called as Muta rotation. Muta rotation is nothing but inversion of cane sugar. The cane sugar, that is sucrose, had one value. Now I'm going to get a negative value because of the reaction happening, right? And you must have seen what are reducing sugars, what are non-reducing sugars, right? What are reducing sugars, people? What are reducing sugars? What are non-reducing sugars? Go on. I know you know it. Again, it will be one more whistle, guys. 3 whistles, it's done. Okay, so one more whistle will come. Okay, so yeah, what do you mean by reducing sugars? What do you mean by non-reducing sugar? Fine, if I ask you, is fructose a reducing sugar or non-reducing sugar?
It's a reducing sugar, sir.
Fructose is a reducing sugar. Okay, what about sucrose? What about sucrose, the cane sugar? Is it a reducing sugar or a non-reducing sugar?
Non-reducing sugar.
Okay, right. So that means you don't know what do you mean by reducing and non-reducing sugars.
So reducing sugars show positive result on reacting with tolerance reagent or failing
Tolerance,
test, right,
then only tolerance?
Tolerance and fillings as well as with beer to water, sir.
Okay, okay, correct. So basically, whichever sugar will give will give me positive. Last whistle, guys. I'm so sorry. Okay, so whichever sugar will give me positive test, right? Whichever sugar will give me positive test for tolerance and fillings, right? Those are what are called as reducing sugars. And I don't know. I don't think so. You know what is tolerance and fillings test? Do you know what is tolerance and filling test? Because I know, I hope that you don't know, because aldehydes, ketones, carboxylic acid chapter is not completed. Only in that chapter you'll be studying what is tolerance, what is fillings, right? What is Benedict's, what is 2,4 DNP. So many tests are there. Right. So anyways, all you have to understand is tolerance and fillings are some tests, right? Which will be given only by aldehydes and ketones. I'm sorry, which will be given only by aldehydes and not ketones. Okay, which will be given only by aldehydes but not ketones, right? But you might have gone to the cyclic structure of glucose and fructose, right? Now you write, if I can, you might have put a straight line, then you would have put H, OH, H, OH, OH, H, all these things that are done for glucose and fructose, correct? Right? Now, same structure, I will be able to little modify it and write it in something called as a hemiacetal form. That is your cyclic structure. You write alpha what is it? It's called pyranoside, something like that. Alpha glucosyl pyranoside. It's something, it will come something like that, right? So all you have to understand is you can have a cyclic structure also for all the monosaccharides which you already know. One is the straight chain structure, right? The other one can be the cyclic structures. Right. So for glucose and fructose, I hope that you know what is the cyclic structures. Okay, fine. You will get into more details of fillings and tolerance in the next chapter. I would say in the next term at least, right? In aldehydes, ketones, carboxylic acid chapter. Okay, but I can give you an overview of how this happens. Let me share my screen, people. It's high time that I share my screen. One note is what I want. Okay, fine. So when I say tolerance test, right? When I say tolerance test, right? Tolerance test is given by something called as tolerance reagent. Okay, tolerance reagent is ammoniacal silver nitrate. Okay, tolerance reagent. What is tolerance reagent? It is ammoniacal silver nitrate. Okay, now how would I write the formula? It's a coordination compound. Okay, so what happens is, if I had NH4OH and if you add AgNO3 to this, okay, ammonium hydroxide, and if you have silver nitrate added to this, you will be getting, right, this complex. Okay, this complex is what is my ammoniacal silver nitrate. Obviously, the counter ion would have been NO3 minus. Okay, so this is my tolerance reagent, AgNH3 twice plus NO3 minus, ammoniacal silver nitrate. Okay, now what you have to understand is, people, this tolerance reagent is a mild oxidizing agent. Right, my tolerance reagent as well as fillings, we'll talk about fillings in a while, right? So this is a mild oxidizing agent. Okay, now what will happen? Say if I had a CHO, right? And remember that tolerance test is given only by aldehydes. Aldehydes only. Ketones will not give this test. Okay, so if I know that there is a carbonyl compound, right? First you have decided that in this test tube there is a carbonyl compound. What carbonyl compound you have, whether it is going to be an aldehyde or whether it's going to be a ketone, is given by these kind of tests, tolerance test, filling test, and all that. Okay, so now if you have an aldehyde and if I put this AgNH3 twice plus, that is your ammoniacal silver nitrate tolerance reagent, you are going to see that, you are going to see that it is going to convert to carboxylic acid, or I'll say the salt of the carboxylic acid. Right, O minus will be there, right? So now what in this process, this is a redox reaction, people. Okay, this is going to be a redox reaction, right? So what is happening to the carbonyl compound? Carbonyl compound is getting oxidized. Okay, aldehyde is getting oxidized to acid. Okay, now what is happening to Ag? You will find that the side product is going to be a silver precipitate, right? This silver precipitate, we also call them as silver mirror. Right, so the moment you add Tollens reagent to a compound containing aldehyde, right, if it is an aldehyde, you will see that there is going to be this silver mirror formed, and that confirms the presence of an aldehyde or aldehyde only, obviously not ketone. Okay, right, this is what is my Tollens test, and Tollens reagent, very, very important, very, very important, at least not in this chapter, but in the aldehydes, ketones, carboxylic acid chapter, it is very, 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 very important. Okay, right. So next one is my Fellings test. Okay, right. Now again, what you have to understand is what is the reagent used. Again, this is given by only the aldehydes. It is given only by the aldehydes and not the ketones. Cool. Right. So what is the Fellings reagent? Right now, you have last time you had only one solution, that is ammoniacal silver nitrate solution, only one solution, right? But in Fellings, people, Fellings is going to have two solutions, that is Fellings A, and you will add this with your Fellings B. Okay, Fellings A and Fellings B will be added together to form the Fellings solution, or I would say Fellings reagent. Okay, now obviously you have to understand what is Fellings A and what is Fellings B, right? Anybody wants to comment? What is Fellings A? What is Fellings B? What is Fellings A? What is Fellings B? Anybody wants to comment? Okay, so what you have to understand is, people, Fellings A is some copper 2 plus solution. Okay, right? So it is going to be some copper 2 plus solution. Okay, and Fellings B is going to be sodium potassium tartrate. Okay, Fellings A is some Cu2 plus solution. Okay, and Fellings B is going to be sodium potassium tartrate. Sodium potassium tartrate is nothing but a salt. It is also called as Roche-Lase salt. Right, it is also called as Roche-Lase salt. Okay, fine. So you do not know the structure of this, not required. Right, now all you have to understand is sodium potassium tartrate, that is my Fellings B, reacts with Fellings A, that is my copper 2 plus some salt solution, to form the Fellings reagent. Okay, now again, as I told, this will be given only by your aldehydes, right? CHO, right? And this, if I add my Fellings, again, this is going to get converted into your carboxylic acid, or I'd say the salt of the carboxylic acid, right? And again, it is going to be reduction, right? Here you had Cu2 plus, right? Now this Cu2 plus will convert to copper. And I know this copper is going to be what? Reddish color, or say reddish brown kind of precipitate you will be getting. Okay, so the moment you find this reddish brown precipitate, that confirms that in the solution I had an aldehyde present. Okay, right? So fine. So all you have to understand is, people, Tollens and Fellings are given only by aldehydes. Okay, right? And you have to know what are the reagents used, right? And what is the test? Well, how do you confirm this? Here in case of Tollens, I need to form a silver mirror, right? And in case of Fellings, I need to form a reddish brown precipitate because of copper formation, right? So all these things you have to know, right? So as you told, right, any sugar, right, any sugar which gives me positive test for Tollens and Fellings, right, are what are called as reducing sugars. Okay, are what are called as reducing sugars, and whichever doesn't give, obviously, is what it is going to be called as my non-reducing sugars. Okay, right. Now, if you look at the structure of glucose, I know there is a CHO, right? I know there is a CHO, something, 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 CH2OH, right? So I know this kind of structure exists for glucose or anything which has an aldehyde for that matter. Right, but fructose, if you look, fructose had CH2OH, C double bond O, again it goes up to CH2OH again. Right, this is a ketone now, right? This becomes a ketone, and this is an aldehyde. This is your glucose, and this is my fructose. Okay, right. So we understand that this has an aldehyde, so it will give a positive test. This has a ketone, so this will not give a positive tolerance. So it is going to be a non-reducing sugar. Fructose is going to be a non-reducing sugar, but whereas glucose is going to be a reducing sugar because it gives positive test for tolerance and fillings. Right, but what happens is there is another test. Right, there is another test called as Schiff's test. Okay, there is another test called as Schiff's test, and this is also called as 2,4. Correct, right? 2,4 DNP test. Okay, now this is given by anything which has C double bond. Okay, anything which has C double bond. That means it can be an aldehyde or a ketone. Both of them have C double bond, right? Okay, so this particular test confirms that there is a carbonyl compound present. There is a carbonyl carbon present. This C double bond O is what is called as carbonyl carbon. Okay, this C double bond O is what is called as carbonyl carbon. So if I have a carbonyl carbon, and that definitely will give this positive test for Schiff's. You don't have to understand what is Schiff's reagent, what is 2,4 DNP, not right away. We don't have to understand now, right? But what I see in reality is, if I do this Schiff test on aldehyde, on your glucose and fructose, right? If this Schiff's test was done on this, what is that? Glucose and fructose, they gave negative test, right? They gave negative test. Interesting, right? They are giving, say, glucose at least gives me tolerance and fillings. That means there's definitely an aldehyde present, right? But for Schiff's, definitely it should give, both of them should give a positive test, but both of them are returning a negative test. What exactly is happening, right? The thing which is happening is, people, right, for this Schiff's test to be a positive test, I should have a large amount of C double bond. Okay, there should be considerable amount of this carbonyl carbon present. Only then, if a little amount is there, no, it will not give. I need to have some considerable amount of C double bond O present for this Schiff's to, right, for this Schiff's or 2,4 DNP to be a positive test, right? So what I understand is, this should be the reason that glucose and fructose are not giving me 2,4 DNP positive test. Why? Because the amount of this C double bond O present in this molecule and the amount of C double bond O present in this molecule is not enough, right? Is not enough. How do you mean it's not enough? I see with my bare eyes that this is exactly present in the structure, right? How is it not possible that this is not in considerable amounts, right? That means this structure is not the only structures, or these structures for glucose and fructose are not the only structure which will answer all the possible questions. There is some change happening in the structure of these two molecules, such that this C double bond O's which I have here and here is getting vanished. And that is what is your cyclic structure. I think you must have seen something like this, right? You would have written O with a 6-membered ring, right? You would have written H, OH. Say here I had CH2OH and H, OH, H, H, OH, H, OH, something like that you would have written, right? This is what is called as your cyclic structure, right? Cyclic structure of glucose. This is particularly for glucose. right? Again, you would have known there is some alpha form, there is some beta form, and these are nothing. These are what are called as anomers. I am not going into details because it has already been taught. Okay, right? I'm just going a little fast because this has already been taught. I'm just giving you a quick recap. Okay, so it's all going to be depending on this particular carbon, right? This particular carbon, if I write HOH, it becomes alpha. If I write OH, then H, it becomes beta. Right? They are what are called as anomers. Basically, anomers are stereoisomers, right? These are nothing but stereoisomers. H and OH, OH and H, the orientation is changing, right? The orientation is changing. So they are stereoisomers which differ in structure, with respect to only one carbon. Is it not? Right? This is exactly what is happening, right? These two are stereoisomers which have only one modification, that is in any one of the carbon atom, the orientations are different. Right? So if you see such stereoisomers which are different only with respect to one carbon, those are what are called as anomers. Right? So basically the alpha form of glucose and the beta form of glucose are anomers. Right? So the same way there can be a structure for fructose also. You should know it, right? And then you understand, right? Now you see there is no aldehyde or ketone, right? In this particular structure, and even if you have a fructose structure, it will be a 5-membered structure. Anyways, we don't have to go into details. So what you have to understand is in this structure there is no C double bond O, right? There is no C double bond O, correct? Right? So that is why it is not giving me what 2,4 DNP test. Right, since I do not have an aldehyde or ketone, that is when I don't have a C double bond O in this particular structure, right? That is the reason why this does not give me 2,4 DNP. Okay, but still, how does it give Tollens or Fillings? Right? How does it give Tollens or Fillings? By looking at the structure itself, people. By looking at the structure of any monosaccharide or a disaccharide or a polysaccharide, just by looking at the structure, I will be able to tell whether it is going to be a reducing or non-reducing sugar. I don't actually have to perform the test, right? So how do you decide it? By looking, I'm talking about the cyclic structures, okay? Just by looking at the cyclic structure of any saccharide, any sugar for that matter, monosaccharide, disaccharide, polysaccharide, any saccharide, right? Just by looking at the cyclic structure of that polysaccharide or any saccharide for that matter, I will be able to predict whether that particular sugar is a reducing sugar or a non-reducing sugar. So how do you do it? It is very simple, people. All you have to look for is a hemiacetal. See, I know these terms this chapter should have been ideally taught after aldehydes, ketones, carboxylic acid, but I don't know what CPSE is doing. But we don't have a choice. We have to know what is this. Okay, if in a structure there is a hemiacetal present, then it will be a reducing sugar, right? If in the cyclic structure, whatever be the sugar, right? If you find that there is a hemiacetal present, right, that will give me a positive test for Tollens and Fillings. That is, it is going to be a reducing sugar. Okay, right. Sir, what is hemiacetal? Coming to the point, hemiacetal is a structure in which there is a carbon. Okay, and that carbon, one of the bond should be OH. The one of the bond should be satisfied by OH, and the other bond should be satisfied by an ether, OR. Right? Basically, this is your alcohol. This is your ether. Right? Obviously, other two bonds can be anything. Right? A carbon has 4 bonds. Right? One of the bonds should be OH. The other bond should be OR. Say OCH3, OC2H5, anything like that. OR. R is an alkyl group. Right? So, any structure which has this hemiacetal, which is the same carbon, only one carbon having both OH as well as OR, that is what is called as an hemiacetal. Right? Now let us check that. I know your glucose is going to be reducing sugar, so it should have an hemiacetal. Right? Let us check whether we have it or not. Right? Now look at this. Let me little rub this. Okay. Now look at this carbon, people, whichever I'm marking, maybe I'll draw it in red color. Look at this carbon, what I have, right? Now you see this carbon is having a OH here, and the same carbon is having a OR here, right? Now this carbon is having an OH, right? And the same carbon is having an OR. This is the full alkyl group, whatever it is, right? Now can I say that this particular carbon forms the hemiacetal? Right, this particular carbon forms the hemiacetal, so definitely this is going to be a reducing sugar. Okay, whichever sugar you're talking about, once you find that it has an hemiacetal present, then you can blindly say that it is going to be a reducing sugar. Right, now if I check what is the structure for sucrose, right, I don't have the structure with me. Maybe I can show you this. 1 second, guys. Let me Google it. I want to know the structure of glucose because me drawing will take a lot of time.
So I haven't.
Yeah. Go on.
Hemiacetal bond is present only in fructose or even in glucose, sir?
Hemiacetal bond is present in fructose also. Let us check. Okay, let us check that. Fine. Now we'll finish glucose and we'll finish sucrose and then come here. Okay.
Okay.
Now see sucrose. Okay, let me. Okay, all of you can, I think, see what happened. Why is it coming like this? Okay, view image. Okay, fine. I hope everybody is able to see see the structure here. Right now, see guys. Say if I consider this carbon, hope you're able. Hope all of you are able to see my cursor. Is my cursor visible, people?
Yes.
My
sir.
cursor. Okay. Now, if you see this particular carbon, right, which my cursor is marking here. Now you see this is OR, right? This is O and R. Right, and see, I should have had a OH for a hemiacetal, right? But see what I have. Again, I have a O. Again, I have a R. Right, this is not OH, right? This is not OH. This is not OH. These kind of structures are what are called as acetal structures. I'll write the structure separately, but for now, if there are two ORs, OR, another two bonds, if you have those kind of structures are what are called as acetals. But if I have one OH and one OR, then it becomes a hemiacetal. Right now, here you see in sucrose there is a acetal structure only because there is one OR here and there is one OR here. It becomes a acetal. It is not a hemiacetal, and hence it is going to be a non-reducing sugar. Okay, fine. Let us check. Everybody understood? Is anybody having any question here? Okay, I hope you're following. Right. Say now, if I check for fructose, you wanted to see for fructose. Right. Now fructose, this is a better structure. Right. Now view image. Right. Now if you look at this, right. Now say, fine, I'll take this carbon or this carbon because that is only having OR. Right. Now you see this particular carbon, if I check. Right now, this is attached to CH2. This is not OH, people. This is not OH. This is a carbon atom here. This particular carbon is attached to this carbon. Right. Fine. Okay. Now this carbon is attached to this oxygen. That means it is OR. Right. This carbon is having an OR. Right. Same way, if you check for this carbon is having an OR, but again it is having a CH2OH. Right. So no, this is neither an acetal nor a hemiacetal, but end of the day, all I need is a hemiacetal, which is not there in this molecule. Okay, which is not there in this molecule. So my fructose is going to be a non-reducing sugar. Okay, my fructose is going to be a non-reducing sugar because it doesn't have any hemiacetal structure. Okay, right. So these are the things you have to keep in mind for reducing whether the sugar is going to be a reducing or non-reducing sugar. So I was talking about acetal. Acetal is OR, and two other bonds. This is what this kind of structures are what are called as acetals. Okay, you will study more about them in detail in your aldehydes, ketones, and carboxylic acid chapter. Okay, right. So the structure point of view is very, 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 very important. Okay, the normal structure, the straight chain structure you write, right? And from straight chain structure, why do we go for the cyclic structures? It is because it is not giving me 2,4 DNP. I have to give an explanation, right? Because 2,4 DNP, it is for the carbonyl compounds. It is for the C double bond O. If that glucose or fructose, irrespective of the fact that they have a C double bond O, still not giving 2,4 DNP, that means there is a problem. That means structurally something is different, right? That is why we go for your cyclic structures for all the possible sugars you can have, right? And then obviously, how do you determine whether the sugar is going to be a reducing sugar or non-reducing sugar? It depends on the hemiacetal. Looking at the cyclic structure, you will be able to decide. Okay, and other than that, you might have seen reactions, oxidation reaction with a mild oxidizing agent like a bromine water, right? So you might have known, say, for glucose, whatever, CH2OH, right? Now, if I had put bromine water, Br2 in the presence of H2O, what happens? Anybody knows what happens? This is your mild oxidation, right? What happens? And say, if I had this one, that is your HNO3, which is a strong oxidizing agent, or sorry, say strong oxidation. So what will the products be same or the products be different? I'm telling you, even though you don't know that bromine water is a mild oxidizing agent, now I told you that it is a mild oxidizing agent. So it will oxidize what?
It will oxidize the CHO, sir.
CHO2? CHO2 what?
COOH.
Right. So now it would have become COOH and something, CH2OH. Right. Now, since it is a mild oxidizing agent, it will not be able to touch the CH2OH. But now if you see HNO3, it is a strong oxidizing agent. It will oxidize both the aldehyde as well as the alcohol to form COOH, something, COOH. Okay. Right. I think this is what is called as gluconic acid. I forgot the names, guys. Right. And this is what is called as gluconic acid. Right. Say all these things you have to know. Okay. All these things you have to know. Right. There are so many other reactions. I can have, I think, your ammonia derivatives getting added. But the thing is, all of these reactions actually you will be studying in your aldehydes, ketones, carboxylic acid chapter, right? So for now, reactions are not that important. Even in your exams, for your school exams or your board exams, right? I don't think they will be asking you so much from the reactions part, right? But from the structure part, right? We spent some time on the structures, right? The straight structures, the cyclic structures, reducing sugars, non-reducing sugars, alpha, beta, anomers, sucrose, maltose, all these things, those things will be asked between what and what, right? I told you, glucose and fructose are forming the glycosidic linkage. Which carbon atom of glucose, which carbon atom of fructose, all these things you have to understand. It is C1, C2. Okay, C1 of glucose and C2 of fructose. Very, very important. Okay, all these kind of questions can be asked because since it is going to be your MCQs, they can ask from anywhere. Right, but just know the reactions. There are only 3-4 reactions present in this whole chapter. Okay, just know the 3-4 reactions. Okay, other than that, you don't have to worry much about the reactions, but the structure part, yes. Okay, any questions anybody has? Okay, fine. Guys, I want to talk to you. I should have done this the previous week itself. Right. So what I wanted to tell is, I know that you're finding it difficult for writing your exams. Okay, I know it. Right. You are finding that too. I know that after the pattern of exam has been changed, right? Say from subjective, now it has become objective. That is only MCQs, right? I completely understand the fact that you are finding it difficult. Okay, and it is okay. Believe me when I say this, it's not only you. Okay, it is not only you, all your friends, all the students from all the CBSE schools, all your 12th batchmates, right? All of them are facing the same problems. Okay, so but sir, are you telling me that just because everybody is facing the problem, should I just give it up? No. All I'm trying to tell you is that do not get demotivated, right? You prepare, right? You prepare, and but you have to keep in mind that this, what to say, this particular thing that, okay, it is going to be MCQs, I'm struggling, these things, just take it out of your mind. You normally prepare, right? And obviously, how you prepared for your subjective exams is definitely going to be different from how you will prepare for your MCQ exams, so this your objective exams. Okay, so we all know what is the difference, right? In subjective, even if you write step mark, even if you write some steps and do not arrive at the final answer, you might be given some step marks. Say out of 2 marks, you might be given at least half a mark or 1 mark, right? But we know in MCQs, it doesn't work like that. If you do not get the correct answer, right, you are not going to get the mark for the particular question, right? So obviously, you have to know the nook and corner of the textbook. They can ask only from the textbook, right? They will not ask anything beyond the textbook. Textbook means not your book back exercises. I hope nobody is doing that, on studying only book back questions and going to the exam. No, it is never going to work, right? So please understand that you have to know nook and corner of the textbook, but there's a shortcut to that. The shortcut is, if you have taken down notes, especially for my classes, as far as chemistry is concerned, if it is for my classes, and if you have taken down notes, throw your textbooks away. Really, I'm telling, throw it away, right? But I don't know how many of you, I don't know, for all chapters, I don't know how many of you have taken down notes, right? But if you have taken down notes, it is going to save a lot of time, okay, right? That is the first thing I wanted to tell you, right? Prepare differently, right? You have to understand everything. If there is, see, if generally in CBSE, even if it is going to be only subjective exams, we all know that just by hearting stuff, we will not be able to get marks, right? And now it is going to be MCQs, only objectives. Now mugging up is really not going to help, okay, right? But the thing is, if you ask me, right, if you ask me personally, right, MCQ exams are way more easier than subjective exams, okay? It is less tiring, right? It is less energy consuming, right, according to me, right? Because all you have to know is read the question and get the correct answer. If you already know the answer, there is no thinking here. There is really no thinking here. Either you know it or you do not know it. As simple as that. There is no intermediate state here. Either you know it, you know the answer, you tick it. Whether you don't know the answer, that's it, 0 mark. And that too, if it is going to be competitive exams, I know you'll get a negative mark also. But thank God that you don't have any negative markings here, right? If you just take the correct answer, you'll get the mark. If not, 0 mark. As simple as that, right? So the way you prepare itself should change, right? And please understand, people, right? For subjective exams, even one night or say 1 week or say 2-3 days before the exam, you study and go, you will be able to vomit something and get some mark. But here, it does not work like that. You have to be in constant touch. Only then certain things will register in your mind, right? Say if those things doesn't register in your mind, right, and that particular small point is asked, maybe you would understood the whole picture, right? You must have understood the whole picture, but a very small point you would have missed during studying. And that particular question is going to come in the exam because we don't know where the question can be asked from, right? So obviously you're going to lose the mark. That means what? You cannot underline this. You cannot skip anything. Literally, you cannot, right? Say if it was subjective exam, I could have told that, okay, SN1, SN2 mechanisms you studied will definitely come for the exam, right? Hydrolysis mechanism you see definitely will come for the exam. Aldol condensation you study, it will definitely come for the exam. No, but no, even teachers don't know what is important. Ideally, they should not know because everything is important. We really don't know where the questions will be asked from, at what corner of the textbook they can ask the question from, right? So literally, right, you have to know everything, right? If you are not going to adapt to this, right? If you are not going to adapt to this, I'm so sorry, guys. You are the ones who are going to lose a lot of stuff, right? People who will adapt, right? People who take this up as a challenge and work on it are the ones who are going to come out with flying colors. If you're going to think, okay, I'm good at it, I have been doing the same thing, but now for this time also, even after everything is changing, I am not going to change my methodology, you are the most foolish person on this earth. Okay, as the environment changes, right? Even bacteria, viruses, single-celled organisms, according to their environment, they evolve. We as humans, such a complicated systems we have, we should also evolve, right? There is no, like, even if you bang your head 1,000 times on the wall, nothing is going to change. You complaining, you cribbing, saying that, sir, this is not coming, is really not going to help people. As long as you are ready to help yourself in the sense that at least the first step is to create a mindset. Okay, I know that I'm doing something wrong. That's why I'm finding it difficult. So I have to change my methodology. At least that, if you fix in your mind, that is the first step. I know none of you, literally none of you are even having that mindset. Same way I'll prepare, same kind of efforts I'll give, and I want more marks alone. Sorry, guys, this is not any fantasy movie. This is life. Right? It's high time. It's really high time that you change your methodology. Know anything and everything from the textbook. I know it's difficult, but at least try it. You try and you don't get the benefit out of it, it is fine. At least you tried. You know how not to do it at least. But if you're not going to try anything and expect something out of this, I am so sorry. This is not going to happen. Okay, it is really high time, people. It is really high time. I wanted to speak to you about this even the last couple, but I forgot. Right? I know that some questions in Epsilon Academy's test were little out of syllabus. Some questions were not, which are not there in NCERT were asked, but still, most of the questions were correct. 95% of the questions were correct. And for that 95% of questions, I know 50% of questions you don't know the answers. Because like the way you prepare is the problem. That is where it lies. Right? See, first thing is, start taking down notes. I don't know what happened in the previous chapters. Chuck it, right? At least from this class, not only for chemistry, for all the possible subjects, physics, chemistry, math, right? Make sure you start taking notes. Take notes sincerely. Just because for the sake of taking notes, if you're gonna take, you don't have to take the notes. Please don't spend so much energy, right? But if you're taking down notes, take it down properly. Each and every, see, that too, especially, I don't know whether you understood this. My teachings, my way of teaching will be way more helpful if you're going to go through that particular notes you have taken one more time. Obviously, you will understand whatever I am telling you in the class. That is for sure. At least that I'll make sure, right? But the thing is, in one class itself, in one topic itself, you know how much information I give you. Right? There is so much information for every small details I touch there and there. Some might be required for you, some might not be required for you, but I do not teach for marks. I teach for you to love science, love my subject, love chemistry. Right? So if that's the case, you record literally whatever comes out of my mouth. Right? Make sure that you record it somewhere in a way that you will understand. Again, that is very important. First thing, write the notes sincerely. Second, write in a way that you will understand. After taking down some scribbling, when you go through it, if you don't understand anything, again, there's no point. First, interest. Second, notes sincerely. Third, clearly. These three things you do, then you can check your textbooks. Right? You really can check your textbooks and concentrate only on your notes while you, like, on a daily basis. Right? So we know that you're going to write a lot of exams. Right now, you will be writing part test, full test in Epsilon Academy. Right? So, but for the chapters which are already gone, you cannot do anything. I'm talking about the next term, right? But for this term, people, at least from the textbook, you learn the text, you take the textbook, you read it line by line, right? If you find that something is important, you make a note of it, right? You make a note of it in a separate textbook, in a separate notebook, right? So that way, again and again, you don't have to go through the textbook. So big chapters, say 10 pages, 15 pages of things, you don't have to go through. Anyways, when you take down notes, you will be writing in the form of shortcuts, right? So that will take lesser time for you to prepare, right? If it takes lesser time for you to prepare, you can concentrate. You can say, sorry, it's 1 second, right? So if you're gonna spend lesser time on studying, you can spend more time on practicing. Okay, you can spend more time on practicing. Okay, like see, you can actually start preparing for JEE level, right? JEE and CBSE are not much different. Say 80% of questions are same, right? So you can get thousands and thousands of question papers for JEE and NEET. At least go for NEET level. Like do not even go for JEE. Okay, NEET level chemistry, start solving MCQs on a daily basis. Okay, take chapter test, takes whichever website you can go, or ask the excellent people whether they can provide it. Okay, so make sure that every day is at least some 20 to 30 questions per subject, right? 20 to 30 questions per subject. That is 30 questions in physics, 30 questions in chemistry, 30 questions in mathematics, right? MCQs, only MCQs. Okay, you try to solve, and that is first thing, solving. Second thing is correcting. You know where you went wrong, right? You know where you went wrong. Say the mistakes can be like this. One, you don't know the concept at all, right? You literally don't know jack about it, right? Then what do? You go back to that particular topic, which it's not like entire chapter you will not know. In a chapter, you might not know, like say a particular thing, right? So once you write a test, right? Say the first kind of mistakes you can see is, say you don't know anything. You don't even know what the question is asking. You don't even know what the choices are. That kind of questions will definitely be there, right? So now you identify those questions. So you have to go back to the theory part, right? And check, okay, this is the theory part. Now see whether you can answer the question. Then yes, well and good. You have done your part. Second type of mistakes you can see is, say you know the concept, right? But you don't know the little details of the concept. For example, right? You know that in SN1 reaction, tertiary is more reactive than secondary. Secondary is more stable than secondary is more reactive than primary. Now why? Obviously now you might know the answer. It is because of stability of carbocation. Now if I ask you why tertiary carbocation is more stable than secondary carbocation, why secondary carbocation is more stable than primary carbocation, this is the level of understanding you need to have. For everything you study, ask a why. Right? Ask a why. Why this? Why not this? Okay, tertiary secondary means tertiary secondary primary. Why tertiary secondary primary? How is it that it is more stable? What are the effects? Right? So first kind of mistakes, you don't know anything, you study the concept and come back. Second, you know the concept, but little details you are missing, then go study the details alone and come back. Third are the silly mistakes. It's like say you know everything, say you know the formula, you know how to apply it, but you did a calculation mistake. Those things you cannot do anything, that will eventually improve, right? But the first two types of mistakes, that you don't know anything and you know something but not like little something you don't know, those things you have to improve, right? Now how will you even know what you're not good at? Only if you test yourself, right? So that test writing, that is 30 questions per day per subject, at least 20 questions somehow, right? 20 questions per day per subject, if you can do and correct it the same day, do not push the second day. You have to write the test and the corrections. Correction means going back and studying and coming back and checking whether you're writing you're able to answer the question again. Right? So those two things on a daily basis you do. You don't even have to study. Let me tell you this. Okay. And for the next term, when we go and for this chapter, or a very let's say very less amount of this chapter is only remaining, right? But for those things, for that particular chapter and for the next term, start taking notes, especially for chemistry. For my classes, it is mandatory for you, or it is going to be, I don't know, beyond what's helpful if you're going to take notes. Okay, so two things in mind. Right now, what you can do is start writing tests. For future planning, what you can do is start taking notes. These two you do. right? And before the third thing is go through the chapters, all the chapters possible, right? And start making your own notes for all the chapters, right? For all the 7 chapters or 8 chapters are there for your term 1, right? Go through the entire chapter, right? And start making notes. I will tell you another idea. The idea is, I don't know how the other sir taught you subjects. Like, I don't know, he took some chapters, I took some chapters, right? At least the chapters which I took, that the solutions I took, I think, what else I took? P block I took. P block I think is not enough to study as like if all we did only questions, right? So solutions I did, P block I did. What else I did? What are chapters I did, people? What are the chapters I did? Solutions, P block, then? Sorry?
Electrochemistry we did.
Electrochemistry. Okay, electrochemistry. At least for solutions chapter and your electrochemistry chapter, please go to the videos again. You have the access to the videos. Okay, fast forward it, do something, take notes from there. If you have missed the class or if you're not taken down notes for those 2 chapters, right? Go to the drive, go to the place wherever you have the access to the videos, electrochemistry and solutions chapter, just take down the notes, watch every video again, right? And start making notes. It is a time consuming process, but it is worth it. Trust me. Okay, it is really worth it. Okay, right? So 3 simple things: notes, test, and what is the third thing? Notes, test, and what is the third thing I told? Okay, whatever, right? So these 3 things are going to be very, very, very important for you to even score marks. This is the way you will study for your MCQ exams, not for the subjective exams. Okay, anybody has any questions, any suggestions? Sir, if you can help me with this, it'll be better. I am ready to give anything from my side, right? If at all you want extra class, or sir, like if at all you want me to always help you in online, like you ask me a question, I'll be able to chat with you in WhatsApp. Yes, ready. Online, more online classes, more extra classes, ready. Me giving you any kind of material, if it is possible from my side, yes, ready, right? You just have to let me know, right? It is always going to be give and take. You ask me, I give you. I ask you, you give me. It is always going to be like that, right? Anybody has any suggestions? So this difficulty I'm facing, or say maybe it's not only for me, maybe that so many people might be facing this difficulty. I found the solution. This is working for me. Anything you are free to share, right? Anybody has any comments? Okay, fine. And one more thing is your other chemistry faculty, right? I don't know his name, right? The other chemistry faculty might not be continuing. Okay, he might not be continuing. So I will be the one who will be handling for the rest of the term. Mostly, again, not confirmed, right? So mostly for the next term and from now on, basically, right? 95% that I will be continuing for you. Okay, so you take it as a good news, not a bad news, but you have no choice, right? You are stuck with me, right? Okay, right. So that is about what I want to tell you, right? All I want you to understand is, please do not get afraid, right? We are, what to say? You have so many things to see in life, so many things. Like even I am not that elder than you, right? Like say. But definitely, whatever you have seen, I've seen little more, right? Right. So let me tell you this: you are going to have a very fruitful experience from now on. Trust me on this. Everybody is going to do great, right? And how everybody will do great, irrespective of what you do, all you have to do is believe in yourself, right? Whatever be the obstacle which is going to come, sir, I am going to make sure that I face it. Whether I win it or lose it is secondary. But facing with courage, that is the most important thing, right? And face it, just alone facing is not enough. You have to prepare yourself for the battle, right? You have to prepare yourself for the battle, then face it. And then the result really doesn't matter, right? At least you will have the satisfaction that you fought and you lost. You can, like say, go down with a straight head, That is all that is important. Okay, not everybody is an Einstein here. Not everybody is made a Madame Curie here, right? We are all normal human beings, right? Everybody has their own struggles, right? If there is no one person, even Mukesh Ambani, the India's richest person, or say Asia's richest person, he will have his own kind of troubles, right? We have our own kind of troubles. So what you understand is everybody in this world has their own kind of problems, and every day they fight with it. Every day, on a daily basis, they fight with it, right? So if your mom and dad would have thought, oh no, this raising a child is so difficult, and they threw you away, right? Say this, I'm seeing like I don't want to like what to say. This guy or this girl, no, they are so much naughty. I'm not able to handle them. I'm going to throw them away, or I'm going to give it to someone else. If they would have given up on you, will you be in this state? Will you be having such a good life? Obviously not, right? They didn't give up on you, so you don't give up on yourself. So many people are having trust in you. Why not you trust yourself, right? Make sure that everybody's trust is not going to waste, right? See, it is not based on result, people. Again and again I'm repeating, it is not based on the result. It is not based on the marks. It is about how you take it. Okay, this is the situation in hand. This I will fight, right? And I will prepare accordingly. And then if the benefit doesn't come, that's all right. That is some maybe bad luck, right? But without even you trying and then you losing is covered. It's being a coward. You know what is covered? By an anguli. Okay, we don't have to be like that. At least we will try, we will fight, and we will try to win. Put our maximum efforts. Okay, right? So this pep talk was necessary for you, necessary for me, right? So I hope from today, right from today, you are going to change your entire routine, entire methodology, and do what is required, right? See, I am just telling you my suggestions. Okay, if you study like this, it might be better. But if you find your own way of doing better, do not even think, okay, sir, do not even think. If you find that that's good for you, you go for it. Right? And tell me also, like you can share with your friends, okay, hey, this I did, it worked for me. You also try, because everybody is suffering, people. Everybody in your class, everybody in any CBSE school in 12th class is suffering, right? So your one suggestion, one small suggestion will help a lot of people. Okay, and how will you find out that small suggestions? Only if you try something, right? Right? You try something, you try 10 different things, your friend tries 10 different things, at least two will work, 4 things will work, and then you share that 4 among yourself. This is how we have to move forward. Okay, there is only one path, right? And we have to take that path no matter what, with a brave heart. Right? I hope I made my point very clear. Okay, there is no running away from this, people. There is no running away. Okay, all you have to do is fight and go down. Fight and win, or fight and go down. Right? Okay, fine. Let me share my screen. We'll continue. Okay, so that was about your carbohydrates, right? So next thing, obviously, you have to speak is proteins. Okay, see, people, this entire thing, right? This biomolecules chapter is a branch of chemistry, right? It's a branch of chemistry called as biochemistry, right? Or I can even call it as chemical biology. Okay, this basically what will we study, what will we be studying in these kind of chapters is, I told you that there can be millions and billions of chemical reactions happening inside your body. Okay, now how that reaction happens, what is the reactant, what is the product, what is the catalyst used in, I'm not talking about all inside your body. Okay, all these things only we'll be studying about in biochemistry or chemical biology. Basically, you will study about sugars, right? You will study about proteins, right? You will study about DNA, RNA, right? And you can even study about this fats, lipids, right? So basically all these are chemical compounds, okay? All these are nothing but chemical compounds, right? So chemical biology or biochemistry is a study of all of this, right? How each reaction happens and so on and so forth, right? There is this thing called as, like, let me make you a little interested, okay? There is this thing called as central dogma of molecular biology. Okay, central dogma of molecular biology. What do you mean? What do you mean by the central dogma? The entire chemical reactions which can happen inside your body, right? I told you there can be thousands and millions and billions of chemical reactions which can happen inside your body, right? All of them are based on this particular point, right? This is the central point for every biochemical reactions which can happen inside your body, right? What is the point? Let me tell you, right? So the thing is, people, we know we have DNA, we have RNA, we have proteins, we have sugars, we have fats, we have lipids, we have everything inside our body. Where are they created from? The body synthesizes its own things, right? Our body synthesizes our own proteins, own fats, own sugars. Obviously, we take diet from that also, as we got, but the reaction point of view, I'm telling you, right? Say this central dogma says, I have DNA, right? Now I know DNA we get from our parents, right? We know that, right? This at least we know DNA carries the hereditary information. Okay, now this DNA undergoes a chemical reaction to form RNA. Okay, this DNA in our body, this is the step. Okay, this is how RNA is produced from in our body. Okay, so I have the parent, from the parent to the offspring, the DNA is transferred. Okay, now this DNA, it is converted into RNA, and this process is what is called as transcription. You don't have to know this, don't worry, I'm just telling you. Okay, so this conversion of DNA to RNA is what is called as transcription. So where do I get RNA from? From DNA I get. Okay, next, what happens is this RNA then converts itself to your proteins. Okay, this RNA comes through some chemical reaction, converts itself into proteins. Okay, and this particular process is what is called as translation. Okay, how many of you are biology students here? Anybody from biology, not from computer science? Anybody?
Yes, sir.
Okay, do you know this? Transcription, translation, have you heard these terms?
Yes, sir. Molecular base of
Good. Right. So anyways, so DNA converts to RNA, and that is called transcription, right? And RNA can convert to proteins, it will convert to proteins, and that process is what is called as translation, right? And what you have to understand is this RNA can also get converted to DNA. Okay, this RNA can also get converted to DNA, and that process is what is called as reverse transcription. Doesn't ring any bell, guys? Reverse transcription, even though you're not from biology, but in day-to-day life, are you seeing this term very frequently? Where are you seeing it?
To identify
Real life.
somebody's parents.
Sorry?
To identify a person's parents.
No, we are now recently in our newses, in our day-to-day life, we are actually seeing this particular term so many times. Where are we seeing this? I say for the past 1.5 years. What big thing is happening?
The study about COVID, sir, the virus.
Okay, COVID. What is this? RT. So this is what is my RT-PCR, people. RT is reverse transcription. Okay, what am I doing? Basically, this COVID is there, right? COVID-19 is a virus. Right. Now, viruses can be of different categories. Okay, this particular SARS-CoV-2, this is the virus name. Okay, COVID-19 is the disease. Right, COVID-19 is the disease name, and what causes COVID-19 disease is this virus SARS-CoV-2. Right, now this is an RNA-based virus. right? This is what is called as, this SARS-CoV-2 is a RNA-based virus. Okay, so now let me tell you the full form of RT-PCR. Okay, RT I know is reverse transcription. PCR is polymerase chain reaction. Okay, right? RT, reverse transcription polymerase chain reaction. Okay, so all you have to understand is PCR is a machine, right? PCR is a machine which will make copies of DNA. Say for example, what does a PCR do is I will give one DNA, right? It will make it into 1,000 DNAs. That's what PCR does. Polymerase, you can see. Okay, polymerase chain reaction. Chain reaction means what? Through a chain reaction, one DNA is converted into so many copies of this particular DNA. Okay, and please understand, PCR can do only with DNA. It cannot work with RNA. Okay, PCR, normal PCR, right? If I don't have this RT, okay, if I have a normal polymerase chain reaction machine, it can work only with DNA, right? Now that, so the PCR can work only with DNA, and we see that SARS-CoV-2 is a RNA-based virus. That means it contains only RNA. It does not contain any DNA. Okay, it contains only RNA. It does not contain any DNA. Okay, so this RNA, obviously I have to do the test, right? When we take the swab, right? I don't know how many of you have done the test. Like you must have seen that they'll be inserting a swab inside your mouth or nose, right? And they'll be putting it inside a solution, right? Now that solution will contain the RNA. Okay, that solution, the swab which they take, will contain the RNA. Okay, now that RNA will be isolated. Basically, that will contain a lot of things, like so many body fluids, saliva will be there, phlegm will be there, so many things will be there. So from that, the RNA is isolated. Okay, now that isolated RNA is given to this RT-PCR. Okay, so in RT-PCR, the first step is reverse transcription. That means the RNA of this virus is converted into the DNA, or not the virus, it is converted to DNA counterpart. Okay, and this DNA is given to the PCR. So many copies of DNA is produced, and somehow, right, somehow I will give some color to this particular DNA. Okay, so I'll be able to see that that particular DNA is there, right? That means you are going to test positive for coronavirus. Okay, that means some color. I don't want to go into the details now. All you have to understand is this RT is reverse transcription, conversion of this RNA by based virus, that is the virus, the RNA of the virus to its DNA, and make multiple copies of this, and somehow I'll be able to visualize. Okay, somehow I will give some color to these copies of DNA, and only the copies of DNA which are from the virus will have the color. Again, repeat. Only the copies of DNA which is coming from the virus will have the color. Other DNAs which I have will not have any color. So if you find that particular color, that means that person is COVID positive. Okay, very good information, right? You all should know this RT-PCR. What is the mechanism for this? Maybe if you're interested, even go through this. What do you mean by RT-PCR? Google it. Okay, fine. So all I'm telling is this is the central dogma of biology, molecular biology. DNA converts to RNA, RNA converts to protein, DNA to RNA is what is called as transcription, RNA to protein is what is called as translation, right? And I can have this RNA also getting converted to DNA in some cases, like say in RT-PCR, right? It is always called reverse transcription. All of these things happen inside our body. Okay, all of these things happen inside our body, right? And all these are simple chemical reactions. Okay, simple organic reactions, I call it. Right, these are simple organic reactions. How a DNA converts to RNA, like obviously you have to know what is the structural difference, right? And how RNA converts to protein. All these are very simple chemical reactions which can happen. Okay, right? Obviously we'll be studying with proteins. Now proteins does a varieties of function. Obviously these proteins are further broken down into carbohydrates. I would say sugars. Right, sugars I know, right? Sugars are basically the glucose, fructose, sucrose, all these things will be, that is coming from the protein part. Okay, there is no specific name for this, but still. Okay, right. So these proteins, right? When I say proteins, people, right? Now proteins have different functions in the body. Okay, now say they can act as enzymes, right? I know enzymes are nothing but biological catalysts, right? Enzymes are nothing but biological catalysts, right? Now they can act as hormones, right? Your estrogen, progesterone, adrenaline, right? All these are hormones, right? They can act as hormones, they can act as enzymes now, or they can act as receptors. What do you mean by receptors? We'll speak about it later. Receptor basically means, say, some kind of, like if I touch you, right? If I touch you, some stimulus is created, right? I'm touching you, right? Now that particular, say, function is again done by a protein, but that particular protein is what is called as your receptor. Okay, right? And last one, other way proteins can act is enzymes, hormones. What does hemoglobin come into? Hemoglobin is a, okay, like one more is normal protein, right? Protein in the form of a building block. We know proteins are required for our body building, right? Say so many types of proteins are there. Okay, but these three, or I'd say all the four, are very important. But you're not going to study them in detail. I'm just giving you the information now, right? Proteins, Alzheimer disease. Okay, you must have known this Alzheimer disease. Alzheimer disease is something that is happening to the structure of protein. The structure of protein is very slightly, modified so that that person will get the disease, Alzheimer's. Okay, so many things are there, right? I think I'll stop with this for today, people. Okay, I'll stop with this for today. Next class, we'll continue in detail about these proteins, DNA and RNA. Okay, anybody has any questions you want to ask? I think you have learned something new today, right? RT-PCR. Please go and flaunt with your friends. Hey, I know this. Do you know this? Go and ask them. You know what is RT-PCR? You know how is it done? Let me tell you. You go tell them. Okay, anybody has any questions?
Sir, Alzheimer's is just a disease related to mental disorders, but how is it related to
proteins? Good question. Good question. We'll understand protein. You know that protein folds, right? We know we have primary structure of protein. Secondary. One second, guys. 1 second. Yeah. So we know in brain there is some proteins. Okay. In brain there are some special proteins. Okay. And we know that generally proteins have primary structure, secondary structure, tertiary structure, quaternary structure. I think all these should have been taught. Basically, proteins folds in some form, right? So that they will be able to get a stable structure. Okay. Now, how they fold matters. If they fold correctly, then fine. But if they fold slightly incorrectly, that is the problem, and that is going to give me Alzheimer's. Okay. And obviously that will result in DNA, that will result in RNA, and eventually it will be showing in your body in the form of a brain disease. That's how you see it. Okay.
Okay.
Right. Anybody else has any other questions? Okay,
No
guys.
doubt, sir.
Thank you so much. Yeah. Go on.
I said no doubt, sir.
No doubt. Okay. Fine. Thank you so much, people. We'll meet again. I think it's on Sunday. We'll meet again. Thank you so much.
Thank you, sir.
Thank you.
Thank you, everyone. Thank you.